A description of R's values. One thing we noticed while implementing the interpreter is that R supports a wide variety of values. It has numbers, strings, booleans, functions, lists, vectors, data frames, and environments. The most important feature for our interpreter was closures. In this example, the inner function remembers the value of x even after make adder has finished executing. R syntax and scoping. One thing we found interesting about R is that almost everything is an expression. Most pieces of code return a value, which is similar to WebG4, where every program evaluates to a value. R also uses lexical scoping. In this example on the right, the function f can still access the variable x because it was defined in the surrounding environment. This behavior is very similar to the environment model we implemented in our interpreter. Variable scoping and functions. For variable scoping, our interpreter used bindings that map variable names to values. The code on the left shows an example of those bindings inside our environment representation. Functions in R are also first-class values. The example on the right shows that we can assign a function to another variable and call it normally. Type system. R is dynamically typed and strongly typed. The advantage is that it's quick to prototype and requires less code, but the downside is that type errors are discovered at runtime instead of compile time. The example here shows what happens when we try to add a string and a number. R doesn't catch this until the code actually runs. Compared to type bracket, R gives the programmer more flexibility but fewer safety guarantees. Type bracket uses static typing, which means the compiler catches many mistakes before the program runs. In R, we have to perform many of those checks ourselves inside the interpreter. For example, before evaluating an if expression, we manually check that the condition produced a Boolean value. Would you take a job using R? Overall, we would consider using R in the right context. R is extremely strong for data science, statistics, data visualization, and research applications. It has a large ecosystem of packages designed specifically for those areas. However, we probably wouldn't choose it for large web applications or system programming because other languages are generally better suited for those tasks.